we continue on our polynomial. So before this, we stopped at long division, right? We stopped at this exercise. So this exercise is actually wrong. The question is 3x cubed plus 4x plus x plus 7. So here is x squared. Okay. So now we try to do, this one is 1, 2, 3, 4, 5. We try to do number 4. Okay, try to do number 4. X cubed plus x plus 3 divide by x minus 3. Let me check first. Long division. Alright. Okay, long division. Okay. So let's try to do it together. X cubed plus x plus 3. So, okay. X cubed, oh sorry. X cubed plus x plus 3 divided by x minus 3. Okay, so we don't have x squared here, so I will add x cubed plus 0 x squared plus x plus 3 divided by x minus 3. Okay, first x times x squared. Okay, you will get the x cubed. So here is x cubed minus 3x squared. So you put the minus here, you will get 3x squared plus x. So here is not. Okay, 3x squared plus x. So then plus 3x. So 3x times x, you will get 3x squared. 3 times 3 minus 9x. So minus here, you will get 10x. 10x plus 3. Okay, so here is plus 10. 10 times x, you will get 10x. 10 times 3 minus 30. Minus, so here you will get 33. Okay, put it all into the form, you will get x cubed plus x plus 3 divided by x minus 3 is equals to x squared plus 3x plus 10 plus the remainder 33 over the division x minus 3. Okay, this is how you want to do the long division. Right. So go back to the equation. So we start on 3. So I hope the rest of it you can solve it. So next you will have remainder theorem and factor theorem. Okay. Remainder theorem and factor theorem. Remainder theorem, Bucky, theory Bucky. Remainder theorem, if a polynomial px, okay, if a px is divided by x minus a, then the remainder r is pa. Okay, you have a polynomial px. And then if px is divided, so if px is divided by x minus a, so the remainder r is PA. Means that you substitute the A into this X. Okay. For example, use remainder theorem to find the remainder in the following equation. X cubed plus 2x minus 1 divided by x plus 1. Okay. So our polynomial is x cubed plus 2x minus 1. So this one is the division. So if you look at the division, it is x plus 1. So x plus 1, you compare with x minus a. Okay, it will become your a is equals to your a is equals to minus 1. Okay, so we put a equals to minus 1 into this x. Okay, this one is a. So p minus 1, so minus 1 cube plus 2 minus 1 minus 1 equals to negative 4. So the remainder is equals to 4, negative 4. Okay, so how about b? 2x cubed plus x minus 6. So this one is the p. 2x cubed plus x minus 6. Divide by x minus 3. So x minus 3 compare with x minus a. So a is equals to 3. So you substitute the x equals to 3. You will get the remainder equals to 51. Okay, another one. 3x square root of 4 plus 2x cubed plus x square minus 3. Divide by 2x plus 3. Okay, 2x plus 3. Compare with x minus a. A is equals to negative 3 over 2. So you just substitute negative 3 over 2 into the x. You will get the remainder here. Okay, so now you have to know that the x minus 1. So it must be in the division x minus 1. Okay, let's try to do the exercise. Find the remainder if x cubed minus 4x squared minus 5 is divided by x minus 3. Okay. A, x minus 3. So x minus 3 compare with x minus a. So you will get a is equals to 3. Okay, then you substitute 3 into the px. So a P3 is equals to 3 to the power of 3 minus 4, 3 square minus 5. So, you will get here negative 14. So, this is the remainder for A. How about B? B compare with x minus A. So, your A is equals to minus 2. Right, so you just substitute B, P minus 2. So, minus 2 to the power of 3 minus 4 minus 2 square minus 5. Okay, so here you will get the answer is negative 29. Okay, and then the rest of it you can continue because you just have to find the A. So, here you compare with A, x minus A, it will become negative 2. Okay, here is 2. Compare x minus a. Here you will get 1 over 2. Right? So, next. Okay, let's look at this example. When 4x cubed plus 6x squared plus mx minus 5 is divided by x plus 3, the remainder is negative 83. Find the value of m. So, we know that P A is the remainder. So, now our Px is 4x cubed plus 6x squared plus mx minus 5. Okay, so x plus 3 compare with x minus a. So, the a is equals to minus 3. So, we put p minus 3. So, equals to p negative 3 cube plus 6 negative 3 square plus negative 3m minus 5. Here is equals to negative 83. Okay, and then you substitute all and then you simplify it. You will get the m is equals to 8. Okay, you can check it's correct or not. You just substitute this m equals to 8 and then you put negative 3. You will get negative 83. Okay, try. A and B, remainder theorem. A, the expression for x squared minus px plus 7 leave a remainder negative 2 when divided by x minus 2. X minus 3. Okay, the expression for x squared minus px plus 7 leave a remainder negative 2 when divided by x minus 3. Find the value of p. So we know that our px is equals to 4x squared minus px plus 7. So it said that when divided by x minus 3, the remainder is negative 2. Okay, so x minus 3, we compare with x minus a. So the a is equals to 3. So we substitute p3 is equals to 4, 3 square minus p3 plus 7. Here is equals to minus 2. So you expand it. 3 square is 9 times 4, 36. So minus 2 equals to 36 minus 3p plus 7. Okay, and then you do some algebraic here. You will get negative 3p is equals to negative 45. P is equals to 15. Okay. So for B, you can try on yourself. For B, given that the expression, so this one is the px, leave the same remainder when divided by x minus 2 or by x plus 1. Okay, for this one, you have px equals to 2x cubed plus ax squared plus bx plus c. So when divided by x minus 2, so a is equals to 2. So p2 is equals to the p minus 1. Okay, you just have to substitute into the formula 2 and negative 1. Okay, done for the remainder theorem. Remainder theorem said that if your px divided by x minus a, the remainder is pa. So how about the factor theorem? Okay, factor theorem. A polynomial px has a factor x minus a if and only if pa equals to 0. Okay, if pa equals to 0, so px has a factor x minus a. So means that x minus a is the factor for px. Okay, it must be pa equals to 0. Means that x substitute into a, so you will get 0, then x minus a is the factor. So look at the example, show that x minus 2 is a factor of px here. Okay, x minus 2 compare with x minus a. So the a is equals to 2. So you substitute p2 into the px, it must be 0. If 0, x minus 2 is a factor for px. Okay, so we substitute x equals to 2, so you will get 0. Yes, so by the factor theorem, it is shown that x minus 2 is a factor of the polynomial. Okay, try this one. Determine whether or not x plus 1 is a factor of the following polynomial. Okay, x plus 1. So here a is equals to negative 1. Show that. So we put p negative 1, it will become 3 negative 1 to the power of 4 plus negative 1 cube minus negative 1 square plus 3 negative 1 plus 2. So here you will get negative 1 times power of 4 is positive. So 3 minus 1 minus 1 minus 3 plus 2. So here you will get 3 minus 3 is 0, minus 2 plus 2. So here you will get 0. So x plus 1 is a factor of this px. Okay, so this one number 1, this one is number 2. So you can try for number 2. Okay, Determine whether or not x minus 1 and x plus 3 is a factor of fx 2x cubed minus x squared plus 2x minus 3. So x minus 1, a is equals to 1. X plus 3, a equals to minus 3. So we substitute P1, you will get 2, 1 cubed minus 1 square plus 2, 1 minus 3. So 2 minus 1 plus 2 minus 3. 2 minus 1, 1 plus 2, 3. 0. So it is shown that equals to 0. So x minus 1 is a factor of this fx. So how about negative 3? P negative 3 is equals to 2 negative 3 cube minus negative 3 square plus 2 negative 3 minus 3. And then you will get 0. Negative 3 to the power of 3, you will get negative 3 to the power of 3. Negative 27 times 2, negative 54 minus 9 minus 6 minus 3. Okay, and then you put here minus 54 minus 9 minus 6 minus 3. Minus 54 minus 9 minus 6 minus 3. You get negative 72. So here is not a factor of fx. Okay. So this one is another example. Given that x minus 3 and x plus 4 are the factors of this one, px. Find the value of a and b. So you just substitute x minus 3, a is equals to 3. X plus 4, a is equals to minus 4. Okay, substitute first P3 and then you substitute P negative 4. You will get the simultaneous equation here. And then you substitute and then you solve the simultaneous equation. You will get the A equals to 1, B equals to negative 38. Right? So that's all for the remainder theorem and factor theorem. So we will continue into the partial fractions.